Can you hear me?
Okay, sir. Okay, sir.
So this is another, which they already discussed previous class, generation of microprocessor. This is the microprocessor introduction. This is the first generation. Already discussed first generation. This is the 4-bit microprocessor, and also 8008. This is the 8-bit microprocessor. Okay. Then the second generation, this is the 4004 feature. Okay, this is the up to 9,000, 92,600 instruction execution per second. A per second instruction execution possible up to 29,000. Okay, so this is a simple one. Hello, sorry. This is the just some discussion of generation of microprocessor. Okay. This also this the Motorola, this the Intel, this the Zilog. Okay, all are 8-bit microprocessor. With the second generation. Just some discussion of microprocessor. Okay, I'll submit your Facebook group, please. Okay. Clear? So just this here, generation. Okay. The Pentium 4, the fifth generation. Okay, 9515 there. The I series. Okay, this here, fifth generation. Hello.
Yes, sir.
Okay, so just right, start with Okay, so because they already complete the generation. Today, provide detail of generation. Okay, microprocessor generation. Okay, all right. Can you hear me?
Yes, sir.
একজন রেসপন্স করো মাঝে মধ্যে, তা নাহলে বুঝবো কি করে।
আচ্ছা স্যার, ঠিক আছে।
Hello, sir.
So this is the common block diagram of microprocessor. Okay, common block diagram. This is the ALU, arithmetic logic unit. This is the flag register. Register means memory, you know that. But flag means this is the symbol of instruction. Okay, you know that flag, Bangladeshi flag or Somalian flag. This is the indicate of the identify the Bangladesh. Okay, or identify the Somalia. Okay, so this is the flag. This is the identify the work. Okay, this is the flag register. And timing and control unit, this part all controlling what. Okay, control part. And this is the instruction decoding unit. At first receive the instruction, then this instruction must be needed the decoding. Okay, then transfer to control unit. Okay, this is the register array or internal memory. Okay, this part to transfer internal memory to communicate the ALU, arithmetic logic unit, or data bus. Okay. You know that our total bus transferring process. Bus means this is the transfer process. These are three types of transfer process. This is the data bus, address bus, and control bus. Data bus all time passing the data. These are bidirectional. Okay, data incoming and outgoing all time. This is the data bus. Okay, clear? Incoming and outgoing signal, bidirectional signal of data bus. But address bus only unidirectional, one direction. Okay, outgoing address, our location, create the location, and this is the PC program counter, and IP means instruction pointer. Instruction pointer, this point, this system are execute your data reserving location. Okay, execute the data submit location or reserving location. Okay, create the reserving location. Okay, IP instruction pointer. So this is the address line, address bus. And control bus, you know that control bus all system controlling. Okay, full system controlling is the control bus. Okay, so control bus also bidirectional, only address bus unidirectional. This is the outgoing signal, and data bus bidirectional signal. Okay, this is the part of data transmission. All are clear?
Yes, sir.
স্টুডেন্ট কি আর বাড়লো না তো?
এগুলাই স্যার, যেগুলো আছে।
কেন 7 জন কেন আছে?
সোমালিয়ানদের অনেকে জয়েন দেয় নাই, অনেকে নাই,
শুধু 2 জনই তো আসছে।
2 জন আছে শুধু, আর নাই। 6 জনের মধ্যে 2 জন আর কি।
Okay.
Why? You're here? What's the problem?
Yes, sir. One question.
Abdulaziz.
That is and me only. That is and me.
Why you are absent?
Maybe today this no class. Maybe 30. Hello, sir. Hello?
The sound is very slow.
Yes, sir. Hello, sir. One time again. Again, sir. One time.
Sorry.
Sir, again. Again, one time.
Why your another friend absent?
Maybe, sir. I would be called now.
I know that your badge is active badge. Okay, only one or two person absent in this class, but today maximum Somalian absent. Why?
Because today there is no one. There is no today.
The special day.
And not there. The routine there is no
Your
class.
sound is very slow.
Hello. You hear me? Sir, students,
Yes, but
they,
the sound is very
hello,
low.
sir.
Yes.
Hello.
Hello.
Yes, students they do not know today class routine. Maybe
Class routine?
routine
Class
class.
routine class na aske?
Maybe there is absence day. There is no day. There is no writing. That's what students
It was a class routine change হয়েছে মিথুন মনির?
they do not know class today.
Wait, I'll check.
হ্যাঁ স্যার চেঞ্জ হয়নি।
তাহলে বলছো একটু দেখবো। দেখে নিলাম চেঞ্জ হতে পারে।
Hello, sir.
Yes.
And there is no problem, but uh, next class they will be coming.
Sorry.
Yes, عبد العزيز said introduction مشى maybe link.
I can hear you. I can hear you.
ما كنت استعرض.
Okay, wait.
عبد العزيز خميس
Yeah.
كم page.
What's that? What do you say? I hope you can hear.
তুমি শিওর যে নতুন এটা আসলে একদিন চেঞ্জ হয়েছে মানে
Sir, I called them. Now they are coming. Two Somalians are coming.
thank you.
Hello.
Hello.
Two Somalians are coming. Abdullah and Abdul Hamid are coming.
Okay, thank you. 28. Okay. 28 plus this is the Thursday. Saturday chemistry class. Reporting. Missing your day missing. Okay. Just this winter missing date. Okay. Clear. Saturday, Sunday, Wednesday, and this the Thursday.
Audio in. Bluetooth.
Hello.
অনেকে
Bluetooth connected.
স্যার কনফিউজড হয়ে যায় লাস্টের ডেটটা নাই দেন এটার জন্য লাস্টে মানে কি বার সেটা
আজকে ডেট ফ্রাইডে বুঝ হয়ে যায় কমপ্লিট আর কি
এটা হচ্ছে থার্সডে। বাট এটা আমি দেখি যদি সমস্যা এটা ডেটটা চেঞ্জ করা যায়। ওকে। So this is the total discussion. This is the ALU. Okay. Arithmetic logic operation. This is the class. Okay. All our discussion. This is the internal storage of data. Okay. This is the program counter. Generate the address of the instruction to be fetched from the memory and sent through address bus to the memory. Okay, this is the generator, address generator. Okay, IP instruction pointer work, the address generator. Okay, and also this is the instruction decoding unit. Already discussed. This another part. This is also discussed. Okay, generator. The control signal. Generates the control signal. Internal and external operation of the microprocessor. Okay, so this is the functional block diagram. Simple block diagram of microprocessor. Okay, so now today just overview of 8086 microprocessor.
হ্যালো স্যার
Hello. Hello. কোনো সমস্যা মনির? মনির কি আছে?
তোর নেটে প্রবলেম হয় প্রচুর
আচ্ছা, so now all are using the notebook. Okay, these are characteristics of 8086 and Pentium 1. Okay, this is the short description of 8086 and Pentium 1 or comparison between 8086 and Pentium 1. Okay, so please using the notebook. At first, just use the notebook and just draw to the 3 line this part discussion This the discussion or description. Okay. Past. One number is the introduced. Intro. Introduced. 8086, you know that, introduced 1978. Okay, these are June 1978. June 1978, and these are May 1993. Sorry, 1993. Okay, so then second, number 2. All are noted this. Okay, yeah. Abdulaziz, Yahya, Deba, সবাই হচ্ছে notebook use করো. Yahya is using the notebook and noted this. Okay. Second is the power supply. Okay. Second, power supply. Power supply. Power supply. Both are 5 volt. Okay. 5 volt. Clear? Then maximum clock speed. Okay. Maximum clock speed. Okay. Maximum clock speed. These are maximum clock speed. 806 is the 10 megahertz. 10 megahertz. And this is 100 megahertz. Okay. Can you hear me? Your response question is
Yes, sir. Yes, sir.
What করছো?
Yes, sir.
Number 4. Millions of instruction execution per second. Okay. Number 4. Look at this. Millions of instruction execution per second. Okay. Instruction execution per second. Million of instruction execution. Millions of instruction execution per second. Million of instruction execution per second. These are 0.33 million. Okay, and these are 112 million. 112 million instruction execution per second. Okay, all are clear?
Yes, sir.
Then on-chip cache memory. Number 5. On-chip cache memory. Number 5. On-chip means built-in in the microprocessor. Okay. On-chip. Okay. On-chip. On-chip means built-in. Okay. On-chip cache memory. Okay. On-chip cache memory. On-chip cache memory. On-chip cache memory. Okay. On-chip cache memory. These are 806 microprocessor not available. Okay, no. And these are yes. On-chip cache memory yes. Okay. Yeah. Then number 6. Number 6. Number six is the number of transistor. Number of transistor. You know that number of transistor is 629,000. Already discussed in the previous class. Okay. Then Pentium 1 3.1 million. Pentium 1 3.1 million. Okay. It is the number of transistors. Okay. 6 number of transistors. Then number 7. Number 7 addressing mode. Addressing mode. Okay. Addressing mode is the 8 addressing mode and this is the 11 addressing mode. Okay. Data bus or data line. Okay. This is the 806 data bus. Okay. Data bus is the 16 bit. Data line 16 bit and this is the 64 bit. Okay. Address bus or address line. Address bus. Address bus is the 20 bit. Okay. And this is the 32 bit. Yeah. Directly addressable memory. Directly addressable memory is the number 10. Directly addressable addressable memory is the 2 to the power 20. Already discussed our previous class. 2 to the power 20 means 1 mega. 1 megabit. Okay. And this is the 2 to the power 32. 2 to the power 32. This is the 4 giga. Okay. Yeah. This is the number of pin, 11. Number of pin. Number of pin is the 40 pin. And this is the 273 pin. Okay. On-chip memory management. 12. Number 12. On-chip memory management. On-chip memory management. Okay. On-chip memory. On-chip memory management. You can know yes. On-chip memory management, yes. Okay. And then the actual memory. Actual memory. Actual memory. No. Yes. Okay. Mathematically extra using processor is called co-processor. Okay. Helping processor. You know that processor also work this, but processor all time in extra ordinary work purpose available. Okay, so your helping processor using the helping processor of 8086 microprocessor Helping processor means coprocessor. Mathematical coprocessor, math coprocessor. Processor. This is one. Okay. Math coprocessor. Math coprocessor. This is the 8087, and this is the no. Math coprocessor are not available, but on chip floating point processor. Okay. On chip floating point. This is not available for floating. Floating means fraction. Okay. Fraction calculation not available our 8086 microprocessor, but fraction and equation fraction result available our Pentium 1 processor, because this is the on chip floating. Floating point processor. Floating point processor. Okay. Support pipelining. Okay. Support pipelining is both are yes. Okay. Support pipelining. Pipeline. Pipeline. Okay. Support pipelining both are yes. Time sharing. 16. Time sharing, both are yes. Okay. Time sharing. Time sharing, both are yes. Then technology. Technology with the ASMOS technology. ASMOS. With the ASMOS. Okay. So this. Okay. All are clear.
Yes, sir.
Now your assignment.
Yes, sir, clear.
Your assignment comparison between 8086 and 8088 microprocessor. Okay, this is the 8086 and Pentium 1. But your assignment 8086 and 8086 and 8088. Okay.
Bluetooth connected.
Again, sir, again.
Comparing meeting
Comparison or characteristics of
comparison.
8086 and Pentium 1.
Hello,
This is
sir.
the 8086 and Pentium 1, but your assignment
Please type, sir.
8086 and 8088. Okay?
Comparison.
Compare. Okay. This already discussed 8086 and Pentium 1, but your assignment 8086 and 8088. Okay.
Okay, sir.
Okay. So now today are another topics, pin and signals. Okay, this is the 8086 microprocessor. You know that our already discussed our 8086 microprocessor total number of pin. 11 number serial. Okay, previously described. Total number of pin, how many pins? কি হলো কেউ কথা বলো না বিভা কি আজকে শুনতে পাচ্ছে
Sir,
না
40.
হ্যাঁ তো এখানে তো দেখা যাচ্ছে তো total number of pin 40. So this is the process total pin 40. These 40 pins designing system at first half and this one okay. So this another half okay. So 1 2 3 4 1 2 3 4 okay. Now counting 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 okay. Another 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 clear all are clear this.
Yes, sir.
And now the numbering system. This is the one. This is the you know that our IC to upper side this is the symbol and left side counting. Okay, this is the counting system left side. So this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, now these guys start 21 22 23 24 okay, 25 26 27 28 29 30 31 32 okay, 33 34 35 36 37 38 39 and 40. Okay, am I clear?
Yes, sir.
So this the total 40 numbers. Now how all things memorize is the very difficult but easier process. You know that our total data line already discussed. Total data line, data bus of 8086. Total data bus number maybe number 7 or 8 number serial.
16 bit sir.
16 bit. Good. Total
8086
8086 total data line. You know that data line 16 and address line
20.
address line 20.
20.
Okay. So this microprocessor address and data this 16 and this the 20. So multiplexed address means A and data means D. So multiplexed AD means address data, multiplexed address and data. Okay, combined address and data 0 to address
20.
data 15. Okay, 0 to 15 total 16. Okay.
Yes, sir.
And now only address A16, A17, A18 and A19. So this is the 16A, this is the 16A, 17 and 18, 19, 20. So total address 20 and total data 0 to 15. Total
16.
data 16. Okay, so this the address and data multiplexed. Okay, multiplexed address and data. This total address and data multiplexed 16. So just this is the memorize policy. This the 16 number serial start. Okay, 16 number serial start. This is the AD0. 16 number AD0. Then AD1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. At first 14 number pin. 14 number pin, this is the VCC. VCC is the incoming signal. Voltage, VCC 5 volt. Already discussed. Our maybe 2 or 3 number point. Okay. So this is the 5 volt incoming, and ground signal, this is the outgoing signal. Ground signal 2. This is the 1 and 20. Okay. This is the ground signal. This is the ground signal. Okay. So at first, design 40 number VCC, incoming signal, 1 number ground, outgoing signal, 20 number ground, outgoing signal. Sorry. Hello. Any problem?
No, sir.
And 20 number, this is the reset signal. You know that reset means refresh. Okay. This is the reset signal. This is the incoming signal. Reset, microprocessor reset. Okay. This signal active means this pin is high. High means 5 volt. This pin is present high voltage. Then this processor is reset. Okay. So last point 40, 1, 20, 21 and 40. This is the 1 ground, 20 ground, 21 reset and 40 VCC. At first this number 4 complete. Okay. All are clear?
Yes, sir.
Now we start AD0. AD0, this is the 16 to finish AD14. But not finish AD14, this is the AD15. This is the mistake. Okay, this is not D. Okay, this is the mistake. Only A. Okay. All are correct. Okay, clear. A16, A17, A18, and A19. All are clear?
Yes, sir.
And you know that our data line already discussed, our data bus bidirectional. Data bus bidirectional, and at this bus only outgoing signal unidirectional. Okay. So this is the address and data multiplexed. So all are bidirectional because all are including data. Okay. So all are bidirectional. This AD0 to AD15, all are bidirectional. Only A, this is the unidirectional address. This 4 address. Okay. 38, 35 to 38. Okay. So total 20 and 4, total 24 complete. 20 and 4. This 20, 16 AD0 to AD15, then A16, A17, A18, A19, A16, 17, 18, 19. This is the total 20. Okay, this is the 16 and this is the 4, total 20. And this is the 1, 2, 3, 4. This is the 4. So total 24 complete. Okay, all are clear? This 24
Yes,
pin.
Yes, sir.
Any problem?
No, sir. No, sir.
No, sir. Clear.
Okay, now this 2 pins. Okay, these 2, this the, you know that interrupt means Ibrahim, sorry, Abdaziz. Interrupt means?
I mean, it's corrupt, maybe corrupt.
Interrupt means
Company, sir. Company name.
just এটাকে কি বলে?
Company name, sir. Inter.
No, it has Intel or yeah, hold on.
Interrupt এই তোমরা বুঝতে পারছো interrupt means হচ্ছে কাজে বাধা ঘটানো, বাধা দেয়া।
জি স্যার বুঝতে পারছি।
বাধা বলতে আমরা এটাতে ইন্টারাপ্ট কি বলবো, ইংলিশে কি বলা যায়? hold the work. Okay, interrupt means just suppose your uh, I talk to you, but in this time your departmental head Abdul Basit just come in this session. Okay, so must be he interrupt this session and we are stopped. Okay, priority Abdul Basit says to you. Okay, so this is the process. So interrupt are two types. Interrupt are two types. These are the non-maskable interrupt and the maskable interrupt. Okay, interrupt are two types. All are clear? Interrupt are two types: maskable interrupt and non-maskable interrupt. Abdul Basit is the departmental head, so his priority, the most priority. Okay, so if he come this session, then must be non-maskable interrupt. Non-maskable interrupt. Okay, but suppose our peon Abdul Gofur or Irshadul just come this session and sir, I says to one notice published. So this is the non-maskable, not this is the maskable interrupt. At first finish our work or my session, my topics discuss topics just at first finish, then he is come this session. Okay. Another he waiting room, hold room. Okay, just wait. This is at first finish this session, then he come. Okay, this called maskable interrupt, and non-maskable interrupt must be acceptable. Okay, priority. Okay, clear? So this is the NMI. NMI means non-maskable interrupt. This signal is mistake. Okay, this both signal, both interrupt signal is incoming signal. This is the mistake. Okay, this is the only incoming. Okay, only incoming signal. Clear? Non-maskable interrupt. And this is the INTR. INTR means interrupt request. INTR means interrupt request. This also interrupt. Okay, both are interrupt pin, but this is the non-maskable, this is the maskable. Okay, this is the peon line and this is the higher authority line. Okay, maskable, this is the maskable interrupt request.
Yes, sir.
Two are request pin and this is the acknowledgement pin, must be permitted pin. Okay, this is the request pin, both are must be request to me. Okay, then I will permission, this is the permission pin. Okay, 24 number pin is the permission pin. Interrupt acknowledgement, this pin in his bar means zero signal active. If this pin is low, then this signal is active, this work is active. Okay, if not bar, all are 5 volt active, all, but this signal 0 volt active. If this pin is low, then this pin is active. Okay, clear?
Yes, sir.
This is the interrupt acknowledgement. So 3 pin are interrupt pin, 2 is the interrupt request pin, and 1 is the interrupt acknowledgement pin. Clear? 17, 18, and 24. All are clear? These 3 pins. 17, 18, and 24. Clear?
Yes.
So these 3 pin are interrupt pin. All are clear?
Yes, sir. Yes, sir.
And this the 90 number pin is clock pin. Clock signal input the clock signal. Okay, how many times work this session? This is the counting session. So this is the signal, clock signal. Okay, 9 number pin. This is the incoming signal. This is the clock signal. Clear? And 24 must be outgoing signal, and this is the 0 signal active. This is the interrupt acknowledgement pin. All are clear?
Yes, sir.
So this all part finish, and this some part finish. Okay, now we discuss this is the ready pin. Okay, ready pin. Our peripheral device. You know that our peripheral device, our keyboard, mouse, monitor. This is the peripheral device. Okay, peripheral device are two types: slower peripheral device and faster peripheral device. Suppose our printer, this is not faster device. This is the slower device. Okay, at first you press the command print, start the print. So just one minute. Hello.
Hello. Hey. عدد. المغلب. ما كبحي. Hello. حال. مقلي. يا. مقلي. المقلي سريع. ها عادي مقلي. ما أعرف مو بعد وقعد. كول بقى يعني. أو وقعد ما صار حاسم عاد أفكر آخر القصة صار. هاي. آخر القصة والله عاد من المقلب بقى. صور بالك صور الحمد لله يقولك عشان كذي كان لقي شكا شبه قاعد حيدي وقع عيد قوي وين
يا يحيى أتوقع سلام
لا دمج مشاهد
صدقني سلامتي يحيى محمد سليمان فضيلة الشيخنا شيخ لماذا عبد العزيز معارض به
أنا معارض
هي أنا رحت عبد العزيز
بعد عسول وانا او ما قدرتش اقول يا بعد والله والله توصل لي سهل بعد من امس ولا مقلي عاد شويش والله يا ايه ده ماما والله بعد انا كده وراك وراك عاد ما مقل سامك ما عرفت يده هي يعني اعرضك وحده ولا كوك
يا أبتي
روح ما ولا كوك
عاتل
كوك خلع عيالك روح ما ولا
حمود
كوح
ها وأركب بدها يوحى والدي فراك قاعدين
ولا مدد بلدي
كوب قدوميه لدانو عيارية
والله على الدكتور بس
كوب قدوميه لدانو عيارية
كان قدامي يا
اسكتوا قدوميه عبد العزيز فوق عبد العزيز ده قدوميه كوب قدوميه عيارية
هو عيار يعني
يا
من عيار لو عيار من عيار يعني
ولا كل قدوميه عيار عبد العزيز قدوميه العمر
ده واتش عليه في عمره عبد العزيز حقها جوده عيار على يوم وتيس مريض عارف تصور ولاده ما ديلا لو شيء حقوق بحسن
هات وين قاعدين حلب حصاد مع وين ما تنتبه هي
لا بقول لي ايه راح يخلص
كانت عويه كيف تريقه
اروح اسوي ليفل
ها ما هي
اروح اسوي
xiisadii hore way dhamaatay be
تمشي كلام صعب
dhowlaya
cadays xiisadii hore way dhamaatay
kii kalgalaya 12
So, just our solar peripheral device, suppose you command what our printer, microprocessor just command throw, print these documents. So, huge time lost the printer, okay? One to one print, then print and print, okay? But processor very faster device. All are clear?
Yes, sir.
So in this time, our peripheral device command throw at first microprocessor, I am ready. Then microprocessor throw the data, this the data line, okay? Throw the data your printer. Okay, at first this is the printer passing through, I am ready, this is the ready signal, okay? Printer or any peripheral device, okay? Clear? And this is the test, means our peripheral device or another device are at first through microprocessor, please test this work, okay? Then microprocessor testing work active, okay? This is the test signal. And this ALE signal, this is the very important. This is the address latch enable. ALE, address latch enable. All are clear? ALE means address latch.
Let's let enable.
Our this the double address and data, address data, okay? Both work, but at a time both work not possible, okay? This 16 number, AD0 to AD15, these the both work, okay? Address and data, okay? So at a time both work not possible. This ALE, if this ALE active, then address latch enable, address line enable, and this is the data line enable, DEN, this is the data line enable, okay? Clear? This is the address line enable, this is the data line enable. All are clear? 25 and 26.
Yes, sir.
This data line, if data line enable, this pin is low because bar. Okay, so this 26 number pin low signal output. Okay, then address line, sorry, data line enable, and this the 25 number pin high, then address line enable. Okay, all are clear?
Yes, sir.
Now 27 number pin, this is the data transmit and receive. So data transmit and receive must be this the bidirectional, okay, but this the unidirectional. Why? This not the data transmit and receive, this the data transmit and receive signal. Okay, if this the DT and R bar, okay, these the both work, one pin both work, okay, double work. This pin is double work, 27 number pin. So DT means data transmit. If this pin is high, then data transmit your data bus. You know that data bus bidirectional, data incoming and outgoing, data transmit. This data transmit, data transmit. Okay. And these are receive signal high, means 27 number pin is low. 27 number pin is low, then data receive active. Okay. Data receiving. If data passing, then data transmit, means 27 number pin high. If 27 number pin high, then data transmit. If 27 number pin is low, then data receive. All are clear?
Yes, sir.
Okay. Then 28 number pin. This is the M-IO bar. M means memory and IO means input output. This also double work. Also double work. If this pin is high, then memory system active. Our memory, hard disks, our secondary memory or RAM, our primary memory, all memory part active.
স্যার আমার ফোন তো লো ব্যাটারি বন্ধ স্যার ক্লাস আর কতক্ষণ নেবেন আমি ফোন চার্জ দিয়ে আবার আসতে পারবো ক্লাসে ক্লাসটা কতক্ষণ কন্টিনিউ করবেন একটু জানাচ্ছেন
আর বেশিক্ষণ নিব না আজকে ল্যাব নিব না তো এই পিন নাম্বার গুলো শেষ করে শেষ হ্যাঁ
আচ্ছা স্যার
কত বাজে 12টা বেজে গেছে এই আর বেশি নিব না হ্যাঁ ওকে সো this is the memory and IO bar. Memory and IO bar. All are clear? IO means input output. If this pin is low, 20 number pin is low, then input output system active. Is this 27, 29 and 32? These three are at a time work. That input output read or input output write. This is the write signal. Write means writing. Okay, and read means reading. Okay, so memory read, memory write, input output read, input output read, input output write. These three are at a time active. Okay, all are clear? These three at a time work. Memory read, sorry, memory read, memory write, input output read, input output write. Okay, clear?
Yes, sir.
And now this another error. Okay, so our three errors. This NMI not bidirectional, this is the unidirectional, this A not A6, AD16, AD17, this is the wrong, A16, A17, A18, A19. This is the second wrong, this is the first wrong, this is the second wrong, and this is the third wrong. This is the hold. Okay, this is the input signal, hold. Hold means our peripheral device request to microprocessor hold your work. Okay. Then microprocessor its work hold. Then if hold, then microprocessor acceptance signal. This is the hold acknowledgement. Okay, suppose this part are using our another microcontroller using this computer system DMA. DMA means direct memory access. This is the microcontroller. Okay, this DMA work. You know that suppose we need to data transmit pen drive to hard disk or hard disk to pen drive or our mobile data transmit our computer system or computer system to data transmit our mobile part. This only data transmit, not process. So only data transmit part, this not active our full, no need our full processor work. Okay, this only transmit part. So microprocessor are involving another controller, this controller named DMA controller, direct memory access. At first our peripheral device, suppose our pen drive request to DMA. I will transmit my data, okay, in hard disk. Just request pen drive, request DMA. DMA request to microprocessor this hold pin. Okay, microprocessor then hold means individual work finish, then data line free. This is the data line. If data line free, then microprocessor acknowledge to DMA. Acknowledge. Okay. Yes, I acknowledge you. Then DMA acknowledge the pen drive. Pen drive. Now you transmit your data using this data line. Okay. Your pen drive to hard drive. Okay. Hard drive. So now transmit this data pen drive to hard drive using data line, and DMA controller control this section. Okay, all are clear?
Yes.
Yes, sir.
So this the using hold and hold acknowledgement. HOLD hold and hold HLDA hold acknowledgement. Okay, this is the incoming signal and this is the outgoing signal. Okay, and this the minimum and maximum pin. This is the very important pin, 33 number pin. Okay, clear? 33 number pin. This is the minimum and maximum. If this pin is high, then minimum system active. Our microprocessor is 8086 microprocessor work two mode, minimum mode and maximum mode. Okay, if this pin is high, then minimum mode active is. If this pin is low, then maximum mode active. All are clear?
Yes.
Minimum mode and maximum mode just difference this 31 to this 24 to 31. These 8 pins, just change this 8 pin. If minimum mode, this 31 to 24, this pin is minimum mode pin. Hold acknowledgement, write, MIO bar, DT, R bar, DNE, data enable, ALE, and INTA, interrupt acknowledgement. These all are minimum mode pin, and also all are minimum mode pin. But if maximum active, then this pin no work. Okay, these 8 are no work. This just change this. These are work. Okay, this 8 is work. All are clear?
Yes.
If maximum mode active, this RQ means request and DT means grant. Request grant 0, request grant 1, lock, status 2, status 1, status 0, Q status and Q status 0, Q status 1. Okay, this 8 pin is active, and this hold acknowledgement, write, IOM bar, DTI, R bar, DNE, data enable, ALE, and interrupt acknowledgement. These all are inactive. But this all active, only this 8 change this 8. If maximum mode, then this 8, and this minimum mode, then this 8. Okay, All are clear?
Yes, sir.
Now, BAC means bus high enable. Our data bus, address bus, and control bus. This bus high. Okay, bus high enable pin. If this pin is low, then bus high enable. Okay, and this the S means status. This the both work 38, 37, 36, 35, and 34. This 5 number status 1, 2, 3, 4, 5. This 3, 4, 5, 6, 7. 3, 2, 7. Total status S02, S7. But minimum mode only active S3 to S7. This is the 5. But maximum mode another 3. 0, 1, 2. 0, 1, 2. Okay, 0, 1, 2. These 3. But these all are low pin, low signal high. Okay, if low, then this is the high. All are bar. So these 3 and these 5, total 8 active our maximum mode. And minimum mode only this 5 work. Okay, status means this is the another work, multiple work. Suppose this 3 means S0 bar, S1 bar, and S2 bar. These 3 are at a time work. This are 1, 2 table, this 0, 1, 0, 1, this 3 means 8 work. 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Okay, then 0, 0, 0, 0, 1, 1, 1, 1. If 3 are low, then 1 work. This 2 low, 1 high. This is the another work. This is the another work, another work. Total 8 work. These 3 status are 8 work. Our next session clear this. Okay, these 3 status. This another 2 status are 4 works. Okay, and request grant. These are almost interrupt request and interrupt grant. Add single pin in request, 1 request and 2 request, double request. Okay, request, grant. Okay, and this also this the status. So this total 40 pins. Okay, all are clear?
Yes, sir.
This pin discussion, all part is discussion. This AD0 to AD15 bidirectional address and data bus. Okay, multiplexed address data bus. These the address data bus to the D0 to D7 and D8 to D15. Okay, and all total D0 to D15 AD. And this is the multiplexed A0 to A15. Okay, AD0 to AD15. Now, this is the A16, A17, A18, and A19. This is the high order address bus. There is the multiplex with status signal. This is the multiplex with status signal. This status signal is another part. Okay, so this part is discussion. Highlight this part. This part. Okay, this is the highlight. This 16. This 16 is this. This presentation slide is very interesting slide. Okay, if this is the active, this discussion active. Okay, this is the discussion. Okay, then this BAC pass high enable. Okay, all parties discussion. This is the minimum and maximum pin. Okay, this pin. Okay, this is the read signal. Okay, this is the test signal. All part. This is the ready part. This is the reset part. Okay, ground. Okay, clock. Interrupt request. NMI, non-maskable interrupt, also this part. Okay, and this is the BCC. Okay, this is the minimum. This is the minimum active. Okay, minimum active means this part is active. Okay, this is the minimum. Okay, this is the minimum, and this is the maximum. Okay, this is the max. This is the minimum and maximum. This minimum all part is discussion. This. Okay, then this all finished. Then this is the maximum. This is the sales. This is the maximum. Okay, this is the status. These 3 status. Okay, read both the triple inactive, then interrupt acknowledgement, then ready output, read output, write output, hold. Okay, then port access, memory, read memory, write memory, multiple work, these three status. Okay, these are queue status, double queue status, quick status. Okay, queue. These are request grant, all parties discussion. Okay, all are clear. So
Yes.
all are study this ping signal. Okay, microprocessor 8086. So today session is finished. Okay.
Sir,
Okay.
hello, sir.
Start the problem.
জি স্যার, ক্লাসটা স্যার যদি দিয়ে দিতেন গ্রুপে তাহলে স্যার ভালো হতো।